It's like I don't care about nothing, man. Yeah. Oh,
So this video is all about translations, which is one of our different types of transformations. So the goal for today, your success criteria, is if you know how to write an algebraic descriptor for a translation. So a translation is a sliding of the object in any direction. This is very similar to what you saw on the very first page when we did the chart. So it goes on to say, in general, we use the following notation to write a transformation that is translated h units along the x-axis and k units along the y-axis. So for the h, that's telling us to go left or right. So this is going to go left or right. So if it's negative, it goes to the left. If it's positive, it goes to the right. The y values, those go up or down. So depending on the h or the k, it's either going to go left or right, up or down. So for the example of our algebraic descriptor, so again, this was our success criteria, is knowing how to write an algebraic descriptor. We'll get a chance to actually do that down here after we label the points and do all this. So it says refer to A, B on the left to find each of the following. So I'm going to label this one as A, this one as B. A is located at, go to the right one, up 3, so it's at 1, 3. B is to the right 7, up 3. So this one's at, whoops, I don't know why I put a Z.
What an idiot.
So 7, 3. Now the length, we can just, instead of having to use distance formula, we can just count since it's a straight line like this. So 1, 2, 3, 4, 5, 6. It is 6 units in length. Now midpoint was one of the things from the very first unit. If you don't remember the formula for it, it's x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So basically you find an average. So my x values go together, 7 plus 1 divided by 2, and 3 plus 3 divided by 2. So 7 plus 1 is 8, 8 divided by 2 is 4, and 3 plus 3 is 6, 6 divided by 2 is 3. So the midpoint is going to be located at 4, 3. So again, we're doing translation. So they want us to translate this line segment AB to left 5 units and down 6 units. So we're going to go to each of the points and we're going to do that. So they want us to go to left 5, so 1, 2, 3, 4, 5, and then down 6. 1, 2, 3, 4, 5, 6. So our new point for A, which is going to be called A prime, so this is building on what we did in the video before. So this one is A prime now because we found our new point, which went to the left 5, down 6. Now B, we do the same thing, 1, 2, 3, 4, 5, then down 6, which would make it right here. And then we can connect the dots. And we created the new line segment A prime to B prime. So A prime is located at, it goes to the left, so negative 1, 2, 3, 4, negative 4, negative 3, because it went down 3. And B is at 2, -3. So that is where both of the points, the new points, are located. It goes on to say, what do you notice about the distance of the new line segment? Well, let's count. This one is 1, 2, 3, 4, 5, 6. So it is still 6 units. So they are congruent. They are still 6 units. So the size did not change. So when we go down a little bit further, this is actually going to build on what we did in the video before. Okay, so now it wants us to write the algebraic descriptor. Now, an algebraic descriptor, whenever you see this word, what it's telling you is what changed. That's what this means. So, what changed with our values? So, every algebraic descriptor will always start with this, x comma y, inside parentheses with an arrow. So everybody should always at least get partial credit whenever it wants us to write an algebraic descriptor, because you are going to go ahead and write this as soon as you see those words.
They've done studies, 60% of the time it works every time.
That doesn't make sense.
Now the next part can be slightly different depending on the question, but everyone starts with this, writing this. Now, for what changed with our x value, we went to the left 5. So since I went to the left, that will be negative. So x minus 5. And we also went down 6, so it's going to be y minus 6. So each point of this figure moved the same direction and the same distance. I was technically supposed to write it the other way around, so the sentence made more sense, but I'm a math teacher, not an English teacher. So it moves in the same direction and the same distance. So both of them move to the left 5, down 6. So since the size did not change like we said up here, this would be an example of a rigid motion. So anytime you see the size does not change, you need to start thinking that, oh, that's a rigid motion. You're going to want to put that in your memory bank. Now, when it's a rigid motion, the distance, length, and angle measures are congruent, which, if you don't remember, means the same or equal. So I'm going to do number 1 and 2 with you on page 4, then the rest is going to be up to you. Now, they say, using the diagram below, what are the images of the vertices x, y, z? For translation, x, y turns into x minus 3, y plus 4. So this is an algebraic descriptor. This is part of our success criteria. Graph the image of the triangle x, y, z. So first thing I'm going to do is I'm going to label each of the points they told me. So x is the one that was at -1, 1. So this is x. Y is at 3, 0. So this one is y. Z is at 1, -3. So this one is z. Now for the boxes that say translation, that's how much is it moving. So they said all the x values are going to be subtracting 3. All the y values, we're going to add 4. So it's going to go to the left 3 and up 4 for each of these points, because we do it to every point, not just one. So 2 ways to do it. I can either just add and subtract to find them. So like if I did that for this one, x prime will be located at -1 minus 3 is -4. -1 plus 4 is 3. So I'll go to the left, 1, 2, 3, 4. then up 3. 1, 2, 3. And this is where x prime is going to be. The other way to do it is just to go ahead and do the counting. So this one would go to the left 3. 1, 2, 3. Up 4. 1, 2, 3, 4. So this would be y prime. So this one was located at 0, 4. And then z, we do 1 minus 3, which gives us negative 2. And negative 3 plus 4 is 1. So I will go to the left 2, up 1 for z prime. Now all your training as a young kid gets to pay off now, because now you're going to connect the dots. And you're going to go, well, golly gee willikers, coach. They look like they're the same size. They have the same angles. So this must be a rigid motion. Now I know it didn't ask for it, but I want to make sure to instill that in you and build on the last video. This would be a rigid motion because the size did not change.
Right.
Okay, so number 2. Using the preimage points and or the graph, draw and label the image after translating according to the xy turns into x plus 6, y plus 2. Use the proper notation when writing the image points. So proper notation is saying it has to have these primes with them when we find our new points and when we graph them. So they were nice enough to already graph the original. We're just going to figure out where the new ones are. So I'm going to do 2 where I just count and then find the points afterwards, and 2 where I do the math and then go to plot it. So for M and A, let's just do the counting. So since it's x plus 6, I'm going to go to the right 6. So 1, 2, 3, 4, 5, 6. And then it wants us to go up 2. So M prime would be right there. Let's do the same thing for A prime. I'm going to go 1, 2, 3, 4, 5, 6, 1, 2. So A prime would be right there. So M prime was located at 1, negative 1. And A prime was located at 4, negative 1. Now for T prime and H prime, I'll just do the math. 6 minus 2 is 4. 2 minus 5 is negative 3. H prime is going to be at 6 minus 5, which is 1, and 2 minus 5, which is negative 3. So T prime goes to the right 4, down 3, 1, 2, 3. So this one will be T prime. And H prime is at 1, negative 3, so right here. So now I can connect my dots, and you're going to go, well, coach, they look the same again. Same size, same angle, same shape. So it must be a rigid motion. And again, it didn't ask for it, but we want to make sure that we know which ones are rigid and which ones are not.
That's what she said.
That's the end of the video. Now, hopefully, you know how to write an algebraic descriptor for translations, knowing that the way it slides is by adding or subtracting from your x or your y values. Now, the rest of this packet is practice for you. So I only did numbers 1 and 2 with you. So the rest of it is up to you to do. Now, if you have questions on it, feel free to message me on Remind or in class about any of the specific questions.